Hello, as you know, my name is Kainton the Genius, and today I'm going to be teaching you data structures and algorithm, and we are focusing on these four items here. Lesson 1, 2, 3, 4, hashing with chaining, universal hashing, perfect hashing, and cuckoo hashing. And if there is any other thing you would like to learn relating to hashing, relating to data structure and algorithm, or relating to even any other topic in programming, database administration, or things like that, just let me know in the description box. Or if there is any topic, maybe machine learning, data science, just let me know in the description box. All right, so I'm going to explain very clearly. I want you to actually focus and learn hashing so that maybe you are doing computer science. I don't know who you are, but I'm sure after learning from me, you are going to understand everything very clear. It just requires you kind of focus, maybe put your phone on vibration or something and take a pen and a paper. So maybe in maybe two classes for one, maybe in 10 minutes for each of the lesson. Lesson one we may take 10 minutes, 10 minutes, and so on and so on up to lesson four. So let's just quickly get started. What is hashing? Hashing, I describe it as a dictionary. Of course, you know dictionary has a word and a meaning of that word, meaning that it maintains set of items, each item with a key. So actually, when we are working with a dictionary, we have two items. We have word and we have the definition or the meaning. Definition or the meaning of the word. So this is the key and this is the value or the item. So in hashing, we are talking about two things are stored, the key and the value, the key and the item as it were. So different operations can be performed. In fact, anytime you are talking about data structure and algorithms, always take note that there are three operations that are important in search, delete, and search. And we are interested in how long it takes to perform this operation. But I just want you to know that after now, in different data structure and algorithm classes, we'll be talking about these operations and how long it takes or performance. Sometimes you may hear of complexity. We are going to discuss all these things in details later on. So for hashing or for dictionary data type or for hash table, all of them actually amount to about the same thing, hash table. So operations can be performed in order of log n time. If you see an order of log n time, it means the performance is really good. But what is order of log n time? It has to do with the big O notation. You need to understand the big O notation. If you don't know it, look at my other video maybe in the description box, or if not, just leave me a comment. I'm going to explain it to you, or maybe send you a link to the explanation so that you understand what it means. Then we also have performance in hash tables can be improved to order of one time. Anytime you see order of one time, is the same thing as constant, constant time, which is actually the best, right? Good. All right, so let's look at the next item, motivation for hashing. Why do we actually need hashing? I've listed these items, but they are not exhaustive. There are many other motivations, other benefits of using hashing. In databases, the underlying structure of database tables is implemented using hashing. Compilers and interpreters, you know of the symbol table in compilers. Network routers maintain routing table. Network servers, when you want to search for substring in a text, maybe a text document or some string of text, string comparison, and so on. Like the internet search, when you search Google, hashing is performed, but now some improved method is used. But traditionally, hashing is what is normally used to search. All right, so these are the motivations for hashing. I'm saying this so that you just be ready to follow up in this lesson easily. The approaches to hashing, there are two of them. One is direct access table. So the question is, what is direct access table? Direct access table is a table that store item in an array indexed by a key. Remember that we say that in hashing we have a key and we have value. So the basic form of hashing is simply an array where we have a list of elements, let's say IT, okay, KM. So let's say these are the elements and they are indexed by key. So it boils down to the same thing. So I have a key, which is the index, and the item inside. So this is the basic form of hashing or basic approach of hashing, which is called the direct access table. But this becomes a big problem. What do you think is a problem with direct access table or array? Let me write it against it so that you don't actually get confused. It's actually the same as array. So the problem with this is that number one, the keys may not be integers. Remember in arrays, the keys or the indexes has to be integers. But in dictionary, in real life, the keys are not integers. They are actually string values. But arrays limit us to using integer keys. It may require much memory because if you are using an array, it means that you need to reserve space for all the elements that need to be stored and be indexing them sequentially. So these are the problems about the simple access table. So how do we solve these problems? How do we solve the problem of direct access table? So that is what we are going to discuss beginning from the next tutorial. I would like to thank you for viewing. Please continue with the next tutorial, tutorial 2, as this will make it easy for you to follow along throughout the length of this course.